Here is the video of us constructing the windmill used in the physics project. First, clip we see here, we start gathering all the materials needed for this thing. Then we start somewhat kind of assembling a rough idea of how we want the base to look. Once we got the base the side down, we decide to put it together. After putting it together, we describe how we want to use the design of the windmill. We figured that cutting pop cans in half and gluing them to a piece of wood attached to this DC-7 motor could possibly work. These were our two rough designs that we used for both the vertical and the horizontal standing windmills. Now, time to get to work. Here's a video of me cutting the can open. This is how we did it. We would take pop cans and cut them in half. Here's my dad finishing one of example pop cans because I don't trust myself with a box cutter because I've cut my hand open multiple times while using them. But our entire goal for this is we're using 4 pop cans for both windmills. One is going to have half standard vertically standing pop cans, and the other, we're going to take the other half and flatten it out and glue them kind of like squares to the base of the blade support things. As we see here, this one's going to be for the vertical standing one, and this one for the horizontal one. Here we have the DC motor, again, that we're going to be using to attach both of these two. Here are the flattened out ones that are going to be used for the horizontal one, and the ones that are going to be used for the vertical one. This is a platform we designed to keep the vertical standing windmill piece attached to the thing while it's spinning, just so it doesn't go flying off. We also need to drill holes for the wires to run through, as so. This is more for the vertical standing one, but here's a video of me drilling holes in a piece of wood. So the vertical standing one will be able to stand up, and the wires will be able to run underneath the structure. This piece of wood specifically was being very stubborn. Next, we begin cutting popsicle sticks for the base of the vertical platform. That one just showed some of the difficulties we were having here. These things were very hard to cut. But once we cut all of them, we cut them usually in like half. This was the platform we decided would work for the vertical one. Here's me taking the multimeter and testing the voltage on a battery to make sure everything's working. And good reading, so we're good to go. Here is the fully constructed vertical windmill blade. And we are going to be placing it on top of the DC motor. As so, we just need to find a way. And we decided elastic bands connected to wood would make the best option to keep it stable. Here is the vertical standing one. It's not going to be placed just like this, but here's the basis of it attached with an elastic band as well, showing how it'll spin. Here is the initial kind of test for the vertical standing one, and as we see here, it spins surprisingly well. We get an average volts from the voltmeter, reading around an average of 1.3. We calculate the average after this before switching it to getting the amps. As we observe, the multimeter is jumping around quite a bit, so we will need to gather an average from after this video ends so we can put in our data. Next is my dad giving me some help with this big fan. This is supposed to simulate a high wind, unlike the last one, which is simulating a small breeze. This one we also tested the volts and amps for because this is what we're going to be using as the primary data of our experiment because we were testing them both in a low breeze and a high wind scenario. Here is me going over to test the amps for it as well. As we can see, the high wind definitely is producing more volts and amps than the small breeze, with the numbers still jumping around quite a bit. Next experiment we tested was with the vertical standing, or the horizontal standing one. Sorry, now that the vertical one was over. The numbers for the vertical standing one, or the horizontal standing one, are going to be in the negatives because we accidentally put on the blades the wrong way. But even though the number is negative, we are reading it the same as positive just because it was a personal mistake we made. But we are already noticing that the horizontal one is reading higher volts and amps than the high wind vertical one. Here's us testing the high wind horizontal. And yeah, this blade is kind of going crazy. But volts and amp, the volts are looking way higher than anything we've seen before. And if we switch over here to the amps, we see this also at a very high capacity. So long that it actually takes the amp meter a second to start reading. Reads, jumps around quite a bit, and the blade is still spinning extremely fast. But this is the exact type of data we want. Here's our last kind of experiment we covered with these fans before recording all the data in the lab report. This was attached to an LED light, and we wanted to see if it would be able to power the light simply with the horizontal fan blade, as we saw that it was producing more volts and amps than the vertical standing one. As you see, the light kind of starts to glow there just a bit. Kind of still hard to see though in the daylight. Or not the daylight, in the light, sorry. But once you crank up the intensity of the fan, you really start to see the light start to light up. This is with the small breeze, and this is the light test in the high wind. As we see, the light immediately kicks on and immediately starts brightly glowing red, so I decided to turn off the lights to get a better visual appeal. And as we see, this thing is glowing bright red. And this was the tutorial on how we made our windmill using CapCut.